This video is going to review some advanced modularization techniques with you, kind of go over the PowerPoint for Chapter 9 just to give you some extra review before our final exam. I'm not going to read all of these slides. These are things that you should be familiar with for the most part. The different parameters are possible. Some have no parameters, return values, etc. You can access this PowerPoint via your online resources. We will talk about each of those in a little bit more detail here. And so every method, as you know, is just a little module. It's a series of statements. You have a method call. You can have an unlimited number of them within a program. Every method has a header, which we call the signature, a body, and then this says it has a return statement, but that's only if it returns a value. The idea here that a method will always return back to where it is called from is what's being emphasized. Okay. The variables that are used in a method, most of them are local, but you can have, if a whole program has what we call global variables, you can access variables that are at the global level in your method. I opened up the animals and foxes and rabbits scenario that is in our Greenfoot folder. Remember, it's the one that simulates population growth, just to demonstrate some of those concepts. And for example, a more global variable would be your instance fields here in your class. And for example, alive would be what we consider like a global variable for the whole entire class. And if I scroll down inside this method, setDead, it uses that global variable alive, but we also have a local variable here, and that variable is world, and that variable could only be used within this method because it's local to this method. So world is a local variable to this method, and alive is global because it's at the class level. Our programming and logic textbook has this example in terms of a flow chart. The variables here at the top are what they would consider global, and over here we haven't seen this, but this oval and is a method, and they designate that with the parens here. And so locally this method would have a variable called language code, and then if we scroll down, language code is used locally there. I don't see that there are any global variables used within that particular method. And so this is just a different way to see how a method might look. When you use flowcharts, this double line right here indicates that it's a method. So you read this, you're starting here, you go to display instructions, you jump over to display instructions, follow that code, and then come back where you left off. So that return statement they were talking about earlier is referring to the fact that you have to return the transfer of control back to wherever you left off. So you have methods without parameters. I'm not going to really emphasize this because you guys have been working with those quite a bit. Just know that when you call it, you have to use the name of the method, and if it has a no parameters, you are not sending it any information. If you have a method that requires parameters, the argument is a value that's sent to the parameter, and you want to write the declaration so that we know that it has a parameter list. And so here's the definition of a signature from our programming and logic book. You have the method's name followed by the parameter list. We've gone into that in more detail. When you send those values in, they are sent in by what they call pass by value, which means they actually copy a value. If we go back to look at our foxes method, these are some of the methods in the foxes program. This particular value right here is a parameter, and when we send the value in, it gets copied to this local variable age. So wherever this is called from, the value that gets sent in is copied, and we use that locally. And that is called passed by value when a copy of the data is sent. So most of the variables that you have worked with are passed by value. However, when you pass arrays, those are passed by reference, which is something we will talk more about in the next course. You can have methods that have multiple parameters and they just have a parameter list, which you guys should be familiar with, and you should be familiar with the fact that there should be a return method, and if it doesn't return anything, that it's a void. So most of this is just an overview, again, just getting you a little bit prepped for your semester exam. This is a particular example of getting hours worked. They designate or have a generic number. You guys would use integer or double here. This is just using a generic example. And then when you use a method, you have to call it with the method name, use any parameters, and realize that if it's going to return a value, you usually have to assign that to a variable, or you have to use that value that's returned somehow. This part of the slideshow is new, and just so that you are aware, there are certain things called IPO charts. And an IPO chart stands for input, processing, and output. And there might be a few questions on your final exam dealing with what we call UML language charts. UML stands for Unified Modeling Language. I just Googled UML diagrams and found a couple sites, but you should be familiar with these, especially if you're going to move on to the next classes, the advanced classes. And Unified Modeling Language is UML, but it's a way for programmers to basically talk to each other and create sketches, diagrams of how things work. This particular example on this page is a pretty common one where you have users, these are the customers, and then you have a bank, and it's a way just to illustrate how things are going to work within a program. And so they're technical diagrams is what they are, and they have all kinds of different varieties. If you take a look, you have there's a list down below here, just a second. You have all these different categories. Class diagram is one that we're going to look at, and a class diagram looks something like this, where it's going to show you, sorry about that, just a second here. A class diagram is going to show you how all of the different objects or classes, like a bank account and a library and a book item, how they might be associated. And so that's another one that we're going to talk about. And so just be aware that there are quite a few different applications that might use UML diagrams if you're going to be a programmer, and you can look up online for more information. For our purposes, you just have to know that they are going to be, or a UML diagram is a way to help organize data. An IPO chart is kind of like a primitive UML diagram. And just a minute here, I need to pause this. Okay, sorry about that. An IPO chart is a primitive UML diagram. It's just it helps us communicate what's going to be inputted into a program, what the processing is, and what the output is. And so just be familiar with IPO, meaning input, processing, and an output chart. And so they are used to identify those three steps. This particular slide is going to talk about passing an array to a method. So we're jumping around just a little bit here. But when you pass an array to a method, you guys haven't done that in Greenfoot a whole lot. But the thing that I want to point out is that means an array is what we call pass by reference. And we're going to cover that more in the advanced classes, but basically it amounts to the fact that they don't actually copy over all the data. They send the address on the computer to where that data will be stored. And so you just need to know that arrays would be passed by reference, where all your other primitive data is passed by value. Overloading methods. There are a couple questions, I believe, on your final exam on overloading methods. And you guys have actually used overloaded methods. You used them when you did your Bubbles programs. And an overloaded method is going to be a shared name but different parameters. That's what you guys want to remember here. They give an example here that the word break could be overloaded to mean several different things, and that's what the term kind of is referred to, is that if you are have an overloaded meaning or overloading something, it means that it can be a single word or a single name can be shared over multiple meanings. And so when you guys used the bubbles, you had overloaded constructors. They had the same name, but they had different parameter lists. When you call an overloaded method, the language translator knows what version of the method you want to use. So if you have the default constructor, it's going to go to the default, but if you have a parameterized constructor, it's going to use that parameterized constructor, which is what you guys did in your bubbles activities. Polymorphism is a word that literally, well, think of poly means many, and morphism is forms, so it's many forms. So it's an ability for a method to act according to the context. And so there it is right there. Polymorphism literally means many forms. So when it knows what to do based on what you have sent it, what kind of object you're working with, then that's what we call polymorphism. And so you might have a move method in one of your programs for different objects, and depending on which object you call, the move method might behave differently. Like when you populated different things on the screens for the white blood cell, like you made them behave a little bit differently when you populated the border versus populating the red cells and the viruses. You did different probabilities, etc. So you were using the same idea, but depending on what the object was, you populated it differently. This particular example is just a business example of an overloaded method. I talked about it in terms of a constructor and a default constructor and a parameterized constructor. This one is just going to talk you through the idea that I could be at a restaurant and we could print a bill with only the balance, or I could print a bill that has a balance and a discount rate. But notice that the name of the method is the same. Print bill is the same. Print bill is the same. It's just the values that are sent are different. They have a couple different versions of this, but just you need to remember same name, different parameters. Overloaded methods, same name, different parameters. You are never required, but they are very useful in programs often. And the advantage is it gives you more flexibility. Predefined methods you guys are familiar with in Greenfoot. You've used the Greenfoot random. You guys have used many of the built-in methods, and every single programming language has built-in methods. If you take the advanced classes, we're going to get into quite a bit of those. And so when you know them or when you use them, this is just like you going to, and your Greenfoot going to your documentation and calling up and looking at the documentation. Now, behind the scenes, we often want to hide the data or hide what is being done, just because a lot of times the users don't need to know everything. So like when you guys did Newton's Lab, you used a, let's see, the vector class, and we don't know how the vector class works for the most part of it, and we really don't care. That's called implementation hiding. Another thing that is in the advanced classes that we'll talk about a little bit more, you might have 1 or 2 questions on your final exam, is something called cohesion and coupling. What you want to remember is that you want to strive to increase cohesion in a program and you want to reduce coupling. What that means is that you want to write code right here. You want to have the internal workings of a method accomplish just that method's purpose. Highly cohesive programs have all the operations are related to that one function, and it makes it easier to debug. It makes it easier to move your code around, and it's more reliable. Coupling is when 2 methods have a relationship. And if it's tightly coupled, that means basically you can't run one method without using the other method. And you really don't want that in a program, if possible, because if you have methods that are tightly coupled, then no matter what, you have to include them in every single program that's ever written that might use one of those methods. And so you want to reduce the coupling if possible. And then the summary slides you guys can take a look at on your own. If I go back one more time to our Greenfoot program and maybe just highlight a couple of those things that they talked about. And I'm actually not going to pull very many of them off the top of my head here. I'm just glancing through to see if we've got anything else that I could refer to here. If we go back and look at our, this down here, location would be an example of a class that the information hiding, basically, they're using that class, but we don't really care too much about what's going on behind the scenes in that, and so they're hiding that information. The toString method is an example of an overloaded method in the respect that almost every object in Java will have a toString method, and depending on what object you send it, whether it's a rectangle or in this case it's a location, it's going to print it out according to the toString method. And that's going to be it for this video. So I would recommend just go through maybe the PowerPoint and take a look at the chapter 9 through 11 notes. We'll have a couple more videos just to help you review, but mostly if you just listen through this before your semester exam, that should help you review.